June 14, 2022-7, a laser is placed in front of a double slit. June 14, 2022-7. So I'm trying to open the examiner report for it. Now, this is a double slit experiment and Young's double slit, and there is a fringe pattern on the screen. The laser emits light of frequency 670 terahertz. Interference fringes are observed on the screen. Explain how the interference fringes are formed. So we had discussed that interference, this actually happens constructive and destructive interference. And when you talk about any question of this type, you have to mention the theory that when waves meet at a point, they constructively or destructively meet. When they meet constructively, it's a bright fringe. And when they meet destructively, it is a dark fringe. The answer, look at the screen, the answer lack the detail required at this level. Rays or light were terms often used instead of waves. So examiner says that at this level, you should use the word waves. Candidates should be encouraged to use correct terms when asked for an explanation. The need for the waves to be coherent after passing through the slits was seldom described by candidates. First, he said you should use the word waves. Then he said you should give the idea of coherence. The description of crest on crest for a maximum is not sufficient at this level. The description involving path or phase difference between the wave that reached the screen should be encouraged. I hope you are getting the level of the quality of answer he is looking for. There were a significant number of candidates who confused path and phase difference. Repeating the words in the question without any further explanation will not get any credit and should be discouraged. A very good point here that the student should not repeat the words in the question. So if you can read the paragraph and you can look here. You can look here, it's a 3 marks question. And he says that we know that what examiner wants. Instead of looking at the marking scheme, we have gone through the examiner report so that we know what is wrong. Definitely marking scheme tells only the possible right answers, how the interference fringes are obtained. So you will start that when waves from coherent sources waves from or we can shorten it, coherent waves, because that can save our time. We can say that coherent waves meet at the screen. Superposition. Where when the path difference when the path difference is n lambda, constructive interference occurs, a bright fringe is obtained. A bright fringe is obtained when the path difference is n minus half lambda destructive interference occurs, a dark fringe is obtained. It is an envelope of dark and bright fringes. It's an envelope of dark and bright fringes alternatively. So this is the answer. I have written the answer after taking the opinion from examiner report. Now, what is the difference between this and using marking scheme? Marking scheme has a limited approach. That is only the true answer. And marking scheme is basically made for examiner, for the checkers, the paper checkers. Show that the wavelength of the light is 450 nanometer. So we have formula that we can use, and we can see the data, and you have 12 centimeter, and you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 fringes. There are 10 fringes. So how much would be the fringe separation?
1.2.
Yes. One point two. So then what we should do?
Sir, we're doing part B, right? The wavelength.
Right.
So then why can't we just use V equal to F
Equal
lambda?
to F lambda.
Yeah.
V is equal to F lambda. 670 into what? 10 power how much? Tera.
12. So that gives us 450 times 10 to the power 9 minus
4,
9.
5.
450 times 10 to the power minus 9.
But you have to move it for 4.5 na.
No, it equals to 450 nanometers then.
450 nanometer. No, but answer, you are saying that actually the answer is coming first. 450 times 10 power minus 9. You're saying that.
Yeah.
Right.
Mm.
The separation of the maxima P and Q observed on the screen is 12 millimeter. The distance between the double slit and the screen is 2 point. What you calculate the separation of the two slits. So he's asking for A. So D is equal to 2.8 meter. To 12 millimeter.
So it will be 7,466.
7, 3.
No, 7,466.
How it's coming so big? Acha 7, 4.
66.
But A is normally very small. So I think this is question 10, June.
Wait, won't it be XD divided by lambda?
X is equal to lambda D upon A.
Okay,
So,
I think I made a mistake. Wait.
check it back, no problem. Check it back. Because this number is coming too big.
Of 1.1 times 10 to the power minus 3.
1.1
Yeah, times 10 to the power minus 3.
minus 3.
Yeah.
Okay. Then Should double check this answer or
Wait, sir, the marking scheme has a different answer. The
wait,
x is 12 divided by 9.
have I counted the gaps wrong? One, two, three, 4, 5, 6, 7, 8. Oh, there are 9 gaps. So it's mistake. Yes. So this is a mistake. I counted it not very carefully actually. 9 gaps. So if we put here 12 upon 9, how much is 12 upon 9?
1.3 times 10 to the power minus 2.
Now we have to check the calculation again.
9.7 times 10 to the power minus 4.
Nine point
7 times 10 to the power minus 4.
the laser is replaced by a laser emitting red light. State and explain the effect on the interference fringes seen on the screen. So what was the previous color? Hmm. He has not mentioned that. Now he's getting red light. So that comes the point where our memory is needed, because we should know that what is the wavelength of red light.
So red light has the largest wavelength, so we can just assume that whatever it was before was smaller.
Was it visible? That's a question also, no? Double check the question, that was it visible or
It said interference fringes are observed on the screen. That's it.
so it's a bit doubtful case, but your point is right. But it's slightly a doubtful case because observation can be made on the basis of machines also. If we take the assumption that red has the highest wavelength, so whatever it is, it has a wavelength less than that. So shifting to red, means lambda has increased. If you check, if you have learned the notes of this chapter, there was a concept of lambda, change in lambda. One thing is observed, one thing is obvious. This is the formula. So x is lambda d upon a. So x is equal to lambda d upon a. And if I have increased lambda, lambda increases a lambda increases, x decreases. So now one thing is obvious, one thing I have done. There are two effects again, which I advise always that we should go for the marking scheme and see what examiner had state here. The majority of candidates stated C part. What is this part? What we are doing?
We're doing D.
Oh, right. The majority of candidates gave the correct description and explanation. So he ran away without giving any explanation. So do you remember about something lambda and angle of deviation, fainter, something like that? One thing is there, lambda increases, fringe separation decreases. So fringe will be fringes when I say x decreases, fringes will be closer. But here, this is a point where notes are important. There are some changes. If you remember the topic under the title of Young Double Slit, and the name of the topic was the effect of changes. Like what happened if I changes the D, what happened if I changes the brightness, what happened if I change the capital D. If I change the wavelength, one effect is obvious, which I had given from the formula. So do you remember the notes?
But sir, if the wavelength is greater, there'll be more diffraction, right? So won't it be like larger separation?
But our formula is saying lambda has increased. We have taken the assumption that lambda has increased. Then if x is decreasing, how we can justify it here? X is equal to, or I am making a mistake again.
But if lambda is increasing, then x also increases, right?
Right, because they are directly proportional. They both are up. Okay. So the second feature, which should be remembered, because we have done one, the second feature will be the image will be fainter, because when lambda increases, degree of diffraction increases. Degree of diffraction increases means the envelope will be less bright. So this is a unique concept, and you should give it, doesn't matter if you find it in the marking scheme or not, but you will find it in some marking scheme and some do not show that concept, that change in lambda changes the appearance of the fringe pattern. So it will be fainter. Now look at this question.
The difference can be that oscillation of transverse waves is perpendicular,
Hmm.
but for longitudinal it's a parallel.
The oscillations are parallel to the wave.
Yeah.
And what is the second? That they both contain oscillation, they both transfer energy. A laser is placed in front of two slits as shown. The laser emits light of wavelength 6.3 times 10 power minus 7. Why an interference pattern is observed? This looks to be a similar question as we have just done, but he had, this time he is giving 2 marks. So we have to shorten our answer we wrote there. Calculate the distance between adjacent maxima.
Will it be 4.5 times 10 to the power minus 3?
4.5, 10 power minus 3.
Yeah.
It seems that this question is made linked with the previous one. When lambda, he has decreased the lambda. So the pattern would be sharper, the pattern would be brighter also. Look at this question. Do you have this question in your book? November
Just
14, 21, 8. November 14th. So this is the first part. And look at the question. Explain how stationary waves are produced. So could you find this question in your book?
yeah, I found it.
So then you should try this question. I'm just coming. I have to say namaz, and you start this question. The majority of candidates found it difficult to relate to the basic theory of production of stationary wave. Those who made an attempt to give a description often gave vague answers. The majority of candidates did not seem to be well prepared for this particular question. So they would benefit from further study of stationary waves. So he has actually criticized a lot. It means majority people are getting it wrong. And we have discussed this concept, I think, in a previous question when we discussed that there are two progressive waves. One is the incident progressive wave and one is the reflected progressive wave. These two progressive waves superimpose these two progressive waves superimpose, and this produces a stationary wave. Stationary wave is produced by the superposition of incident and reflected progressive waves. The arrangement of operators used to determine the wavelength of sound wave is shown. So did you try this part?
Yeah. For the answer, I'm getting 1250. So I can just round it to 1300, right? Because it said approximately
1290.
1250. But they said approximately 1300. So I can just round it, right?
Apparently, it is that case where the sound signal is coming from here and it will hit the surface and then it will like this. So it is looking a case of superposition. The loudspeaker emits sound of one frequency. The microphone is connected to a CRO. The waveform obtained on the CRO for one position of the microphone is shown. So did you get that time period from this graph? What did you do? That is,
Yeah, I multiplied 4 by 0.20 times 10 to the power minus 3.
because there is a y-axis here. And if I take the y-axis on this position, The time-based setting of the CRO is 0.20 millisecond per centimeter. The figure to show. So how much is the time period you are getting? The time period is an how many divisions are there in time period?
I'm getting 4.
4.
Yeah.
Hmm. 4 divisions. One division is 0.2. Now frequency is equal to 1 upon T.
So we'll get 1250.
1, 2.
50.
Good. And what about this one? Explain how the apparatus is used to determine the wavelength of the sound. It's a memory. You have to move the microphone slowly and at a constant speed along the stationary wave. The microphone will detect maxima and minima. You have to put a ruler here. You have to put a ruler here along the. You have to put a ruler here, and this is the meter rule, suppose. So you have to move. You should move the microphone at a constant speed. The microphone will detect maxima, minima. You need 2 successive maxima or 2 successive minima. Suppose if I work on node to node. So I know that node to node is lambda by 2. So if I locate using the CRO, if I locate the separation between 2 successive nodes and then I double the distance, I will get the wavelength. Sorry. So if I measure this distance, T will be equal to lambda upon 2. So if you double it, lambda is equal to 2D. How we do part number 3?
We can use V equal to F lambda. So for this, do we use the frequency we calculated or the approximate one that they gave?
I think we can use 1300 also.
It will be 338.
300.
38. But if I use the answer that I got, will it be fine, or do I have to use the one that they gave?
I think it's fine because examiner will see that you got this answer, and he's also using the word approximately. Logically, 1250 is using 1250 is more logical